Hello, now we'll discuss regarding the design of components subjected to the fatigue loading. Now this design of a fluctuating loading or fatigue loading is being divided into the two broader category, that is a design for the completely reverse stress where sigma m is equal to 0, and design for the purely fluctuating stresses or fluctuating stresses where sigma m is not equal to 0. Then further it will be further classified into the design for the infinite life, design for finite life, and same is the case for the fluctuating stresses. Now let us revise the terminology of completely reverse and for fluctuating stress. Let us one by one go to the that terminology. This is a general diagram of a fluctuating stresses. This is the stress versus time diagram. This is a curve. This is a maximum stress, minimum stress, sigma m mean stress. This is the alternating stress. If this line is going to touch to this line, that means sigma minimum will become equal to 0. That will be called as a repeated type of stress. That is sigma minimum is equal to 0, then sigma m is equal to sigma max plus sigma minimum by 2, and sigma a is equal to sigma max minus sigma minimum by 2. If this line is going to touch to this, that means sigma minimum is equal to 0, then sigma m and sigma a will be equal to the sigma max by 2. Okay, where sigma minimum is equal to 0. If this line is going to touch to this line, that means sigma minimum will be equal to the minus times of sigma max, then sigma m will be equal to the 0, and sigma a will be equal to the sigma max. That will be called as the completely reverse type of stress, where sigma minimum is equal to the minus times of sigma max, therefore sigma m is equal to 0 and sigma a is equal to the sigma max. Now one more definition is there, that is the endurance strength and endurance limit. Endurance strength, it is related to the finite number of cycles, and endurance limit is related to the infinite number of cycles. Then let us see this classification, that is designed for the completely reverse stress where sigma minimum is equal to the minus times of sigma max, therefore sigma m is equal to 0 and sigma a is equal to the sigma max. Then it is a purely fluctuating stress for finite and infinite life. Finite life, infinite life means it is the endurance limit, and in finite life means it is the endurance strength. Now let us see one by one. First one, that is design of a component subjected to the completely reverse stresses where sigma m is equal to 0, means sigma minimum is equal to minus times of sigma max, therefore sigma m is equal to 0 and sigma a will be equal to the sigma max. Therefore, as this loading is the completely reverse, the endurance limit is the design criteria. Endurance limit means it is a for infinite life, therefore sigma a will be equal to the SC by Fs. What is this SC? It is the endurance limit, and tau a will be the endurance limit in shear divided by factor of safety. Now this SC will be calculated as SC is equal to K into KB into KC into KD into KE into KG into SC theoretical, that is by using a modifying factors. Now for the finite life, this is for infinite life. Now for finite life means it is the endurance strength, that is equal to SF. Now for that we will use the RR-More test. Okay, the graph is generated by using RR-More test. The portion from 3 to 6, it is for finite life, and from 6 onward it will become equal to the infinite life. Now that, as we know, that is for endurance strength is the endurance strength value is below the yield limit. Now for irrespective of material type, for the fluctuating stresses we have to use this one. Now that is a RR-More test. Now what is this? This is a log graph is there. Okay, this is a log 10 of 0.9 of SCT, log 10 of SF, that is endurance strength, and log 10 of SC, it is endurance limit. Then 3 to 6, this is the number of cycles, that is the endurance strength versus number of cycles is there. Now if you observe this, AEB and CFB, there is a similar triangles are there, therefore we can write AE divided by CF will be equal to the EB divided by FB is there. That means we'll get to this equation, that is CF divided by FB will be equal to the A divided by EB. Therefore we'll get this equation. After simplification we can further simplify the equations. Now where sigma A is equal to SF by Fs. Okay, what is the endurance strength, and tau A will be equal to the endurance strength in shear. That will be calculated as a 0.5 of SF by using maximum shear stress theory, 0.577 of SF by using a maximum distortion energy theory. Okay, now we'll see, that means we have decided that is for completely reverse stresses, that is for completely reverse stress for infinite life and for the finite life. For infinite life we are going to use the endurance limit as the criteria, and for finite life we will use the endurance strength as the criteria. That is nothing but our SF. By using RR More test we can evaluate the different dimensions of that. Then the last point, a short note will be asked in the examination based on the cumulative fatigue damage. Now what is exactly this cumulative fatigue damage? In certain applications the components are subjected to the different values of completely reverse stresses for different parts of the work cycle. Fatigue life of such a component is calculated by using a Miner's equation. What does it mean? That means if a shaft is there, on the shaft a force is being applied, the magnitude and direction of the force is going to change with respect to time, and the shaft is also rotating. Now each and every point on the circumference of the shaft will be subject to the different stresses with respect to the time, with respect to the rotation of the shaft as well. Now suppose it is being subjected to the 4 different types of stresses, that is sigma 1, sigma 2, sigma 3 and sigma 4. For T is the total time duration for which the cycle is going to run. Now sigma 1 is available on the shaft for n1 number of cycle, sigma 2 for n2, sigma 3 for n3 and sigma 4 for n4 number of cycle. Alpha 1 is a fraction of time for which the sigma 1 is applicable. That means that for the total time, fraction of total time, that means the time which is applicable for which the sigma 1 is applicable, that is nothing but alpha 1 into T. Alpha 2 into T for sigma 2, alpha 3 into T for sigma 3, alpha 4 into T for sigma 4 is there, for which sigma 4 is applicable on the component. Now suppose capital N1, N2 and N3 are the nothing but a total number of stress cycles before the fatigue failure by individual stress acting on the component. Sigma 1, sigma 2, sigma 3 are the completely reverse stresses. N1, N2, N3 are the number of cycles for sigma 1, sigma 2 and sigma 3 are applicable. Alpha 1, alpha 2 and alpha 3 are the proportion of total time. Therefore you will get N1 is equal to small n1, that is the number of cycle, then alpha 1 into total time n, total number of cycles. Therefore we will get the equation N1 divided by capital N1 plus N2 divided by capital N2 plus Ni divided by capital Ni will be equal to 1. Now as we know that is small n1 is equal to alpha 1 into n, therefore we will get this equation, that is alpha 1 divided by n1 plus alpha 2 divided by n2 plus alpha n divided by nn will be equal to the 1 by n. Alpha 1, alpha 2 and alpha plus up to alpha n, it should be equal to 0. Now this is the entirely cumulative fatigue damage based on a chart. Not will be asked and some numericals will be asked. In the next lecture we will discuss regarding the numericals. Thank you.